Hello all, and for this lecture we're going to dive directly into our VBScript looking at arrays. Let's get started. We're going to learn command line arguments to control code at runtime and to feed it various attributes that we may need. We're going to look at reading a text file or using a text file in place of arguments. We're going to learn to create useful error messages if arguments are missing when we expect them. We're going to learn how to use something called a named argument to control the way that the arguments are read in and the order in which they're read in. We're going to create an array to give multiple values to a single variable. We're going to convert text files into arrays. Then we'll finish up by working with delimited strings. And then finally, we're going to explore the idea of a dictionary versus an array. So let's get started. Command line arguments are words or phrases that will follow the name of the file that you're running when you do that C script command. So for example, we've got one here. Here's our C script command. Here is our file name that holds the script that we want to run. And at the end, we've got some extra information. That right there is what we call the command line argument. What it is going to do is going to allow you to input some specific information into a script before you even run it without actually having to change the script itself. On the scripting side, we need to create variables to take those command line arguments. So something like this, we've got str machines, which is a variable, and we're setting it equal to the value of the arguments in the script, and we have item and then parentheses 0. If we use the example we did previously, we had a semicolon in between them. So here we'll say a machines equals split the entire string that we had, but split it at the semicolon. This can be changed to any character. So for example, if you want to put a comma here or a colon or an asterisk or whatever character you want, you can use that split to take that one long single string and break it up into its various components. If the script is going to expect an argument and we do not have any, it will give an error. So you'll get something that looks like this, where it just says subscript out of range, VBScript runtime error. It's not very helpful to our user. So what we want to do is create a useful error message. And we can do that by checking to see first if there was at least one argument. In order to do that, we use the VBScript arguments count. That will give us the number of arguments that were given at runtime. We can place that within an if-then loop, and we can check for any arguments. If there are none, we'll actually create a more useful message that is explaining what the error is about. You can actually make this into a subroutine. So right here, we've got a subroutine that's going to automatically check for arguments. If the argument count is 0, then VBScript echo. Remember that VBScript echo is a way to present information to your user. So you must enter a computer to ping, try this, blah, blah, blah. VBScript quit. So what it is doing here is it's saying, I'm expecting arguments. If you haven't given me any, I'm going to give you a message saying, hey, I need some arguments. And then I'm actually going to quit the script because we cannot proceed unless there are arguments. So it is a good idea to go ahead and put this in a subroutine. Now, a named argument. A named argument helps keep things simple, and it also makes the order in which the elements are put on the command line completely irrelevant. So it's especially easy to, or best practice to use it if you've got 3 or more. If you only have 1 argument, this may not be necessary. 2, you can kind of keep them in order. Once you have 3 or more, you go ahead and use the named. So first we're going to set a command to assign the arguments.named to a variable. Then we're going to create a name for the argument and assign it to that variable, create a second name for the argument, and then just keep going on like that. Then we use those variables just as we would any other normal variable, and the values are going to be assigned to it when the script is run. So here's our example. We've got a variable here called col named arguments. And so we set that column named arguments equal to VBScript.arguments.named. Once we do that, we say computer name can then equal the argument that has the key or the name or computer, and service is the argument that has the word service. Now on the command line, what this looks like is that here we've got a /computer with a colon and then the information, and then /service colon and then the information. So on the command line side, you have a little bit more to do, but what you're saying is my computer name is 127.0.0.1 and my service is a LAN master service. I can actually put those in either order. So if I were to put the /service before the /computer, in this scenario, it doesn't matter. Quick recap on arrays. Array is a collection of something that you can create and control. VBScript does allow for dynamic arrays. And for dynamic arrays, it means you don't necessarily need to know how many are going to be in it before you create the array. So my example script here, I've got my dim command, which declares my variable. So I've got a dimension array computer that's going to just create a regular variable as we've been used to with the ARY at the beginning to indicate that it is an array. Because remember, in VBScript, we kind of have those first couple characters that help indicate what the variable is. Then we're going to populate that variable with multiple items. So if I come down here to this line, my array of computers equals array, and then in parentheses, I give it the values that I want it to have. So in this case, I've got 3 strings. I've got S1, S2, and S3. They're all in quotes. They're all separated by a comma. In order to walk through and use that array, I can use a for each loop. So for each computer in the array of computers, we're going to basically do an output, and then we're going to increment and then go to the next one. For an array, if we would like to use a for next loop, we need to know the number of elements, and we can figure out what that is by using the command ubound, capital U, capital B. And what that is going to do is it's going to tell us the upper bound of the array, or how many elements are in the array. So for example, here I've got my for I equals 0 to upper bound of array computers, and it's going to go ahead and do the echo script. This does the exact same thing as the previous loop, it's just using a different type of loop. If we want to read a text file, first we're going to have to open it, then we parse it, and then we write our results into an array, and then we close our file. So let's take a look at this. Here I've got some variable names. I've got my text file name assigned to a variable in that reference section, and I have a constant for reading equals 1. First thing I do is I create an object using a file system object. I set the object text file to the open text file, and then I give it the text file name, and it is for read only. Changing this for reading number is going to indicate whether you open the file for reading, for writing, for appending, for deleting, etc. 1 is for reading. Finally, down here, I go through a do loop, do until, and I use at end of stream. So I'm going to read through the file step by step until I get to the end of that file stream. I'm going to read it line by line. String next line equals object text file, read the line. Then here I can split it based on either spaces or punctuation or whatever. And then I just do an output, and I'm just doing some echoing here. It's going to keep repeating this do loop until it gets to that end of file. So you open the text file up here, open text file. You're going to read it in and parse it line by line. And as we parse it here on this split, we're assigning it to this array of service list. And then finally, we go through and do whatever we need to do with that text in the file. We can have a two-dimensional array to store related content. Typically, we picture this as a table with rows and columns. We do use the same dim command to declare the whatever variable we're going to use for that array. But in this case, we are going to give it some values. So we're going to say dim, we're going to do space, variable name, and then parentheses. Parentheses, we're going to have the number of rows and the number of columns separated by a comma. We can populate the array by assigning values into that variable name. And then we can use the array name and indicate which position we're looking at, and that's how we can assign values. So let's take a quick look here. We've got our dimension on this line here where it says A33, so it will be a 3 by 3 table with 3 rows and 3 columns. Remember from scripting 1, in order to march through a two-dimensional array, you need to march through each row, and within each row, march through a column. So you need a loop inside a loop. Here we've got our outer loop is our I, so that would be our row, and then for J would be our columns. Here we're just getting the values stored in each. So here I am assigning. So A in this row, this column is going to be equal to the string of loop space number loop. So we're just putting some information about where it is. And then here we're echoing the value stored in that position is, and we indicate the value we want to extract from it by using the variable name, the regular parentheses, and the I and the J. So biggest difference between C and C++ and VBScript here in this way is that your arrays are going to use regular parentheses and not the square brackets. We can work with strings and think of a sentence as just an array of string. So remember back when we did that text file, we can identify a text file to convert to an array by using that file system object to point to the file that we want and then to indicate how we want to interact with it. We've got a few other commands here that we can use. So we've got this instr, and that will parse data very similar to the split, but we don't have to indicate how we want it. So remember, split takes a string and looks for a specific character. instr doesn't do that. We then use the file system object to connect to the data source using the file name. We can use a dynamic array to hold the data. So we don't have to know how much data is in that file before dumping it into an array. And then two commands that we can use going through the strings in a file and the arrays. We've already talked about the U bound, which is the upper bound, but we also have an L bound, which is the lower bound. And when we do our iterations, we can use the L bound and U bound to figure out where to start and stop and where to set those limits as we go through an array. Here's an example file for a script that is going to read through a file and do some manipulation. So over here on the right, I've got some general information. So I've got some variable and I've got some variables, and I've got some commands for the set and the instr, which is the new information we found. So at the top, we've got dimension, array, text array. That's just going to create a dynamic array. Notice there's nothing in the parentheses. So therefore, it creates a dynamic array, which means it'll grow and as it needs to. Here we've got my file, which is going to be the file name, the search string, and that's going to hold a string of what we're looking for. Our object text file is your connection to the text file, and your string next line is the lines being read in from that text file. Init size, or int size, is going to be the initial size of the array, and object f is the FSO object. Now, as we get into the reference section, we're going to set the initial size to 0 because there's nothing in our array. My file name is going to be setuplog.txt. I'm going to search for the word error, and I'm going to create a constant for read only. So basically what I'm doing in this is I'm going through this setup log and I'm looking for any error messages. Next, in the worker section, I'm going to set object FSO to create the file system object. Then I'm going to open the connection to that file by saying open text file and setting it the text name and for reading. Then I'm going to do my looping. Here until the end of the script file, I'm going to read in a line. If in the string it exists what I'm looking for. So here I'm looking for the word error. If the word error exists, I'm going to retain that line of information into the text array. If not, I'm just going to keep reading. Okay, when the loop is done, so it's gone through this text log file, found all of the error messages, and put all of the error messages into the array. I'm going to close my file, and then basically down here in the output section, I'm going to output all of the error messages that were found in that log file. Basic syntax: set object text file, open text file, the file, and then for reading. Here we're using that for reading equals 1. And in string, so you can either start at a specific position, you need to put the string that you want to search and what you're searching for. So whereas split actually created multiple array elements out of a single line, InString is going to search for a specific value within the string, but leave the string intact. We can also parse past text. So for example, let's identify a CSV file to convert into an array by using that file system object to have the connection. In order to do that, we're first going to use that InString function to parse through the data and look for whatever delimiter is being used for that file. We can use the file system object to connect to the data source. We're going to use our dynamic array to hold the data just like we did before. Use our L-bound and U-bound to iterate through the array. And then finally, what we're going to do is use split with that delimiter to break the text into its various elements. Lastly, we're going to take those elements and we're going to put them in a multi-dimensional array. So let's take a look at this code. Here I've got a bunch of variables that are being created with our dim, okay, in the header. So we've got our dynamic array, the file name, the string to search for, the object connection for the file, the next line, the size of the array, the file system object, the increment counter, the error string, and then finally the new array. As I look at the code, everything is pretty much the same as we go down here into line 21. So my header's got all the variables that we're declaring. My reference section does all the assignments of things like file names and things like that. Then finally on line 18, we get into our actual worker section. My CSV file to parse through is here on 14, applog.csv. I'm going to search for a comma because it's going to be a comma delimited file. The error that I'm looking for is a 1004. As I read through the text file, line by line, if there's a comma, then secondly, look, is there an error? If there is, I am going to put the value in my dynamic array, and then I'm just going to continue reading. After I read the information in, it is good practice to go ahead and close the file because you're no longer needing it. Here down on line 32, I've got for I equals the lower bound to the upper bound. Because it is dynamic, we don't necessarily know what the lower and upper bounds are, so we go ahead and use the L bound and U bound. If there is a comma within my string of the value in that array, then I'm going to take that line and break it up with the comma. What we're expecting on these read-in lines are things like date, time, source, server, and messages. So this first one is reading in the file. The second one is actually manipulating the text found in the file, and it is going to split them by the comma. Finally, we end our if, we go back to our next, and we finish our script. Finally, and either your homework or CBC is based on a dictionary object. I don't remember which one, but that's okay. A dictionary object works like an array, except that it is actually stored with an associated key, making it easier to find later. So in an array, we're going to use that index to retrieve an item. In a dictionary, we use a key. So in order to use a dictionary, we dimension a dictionary object dictionary. We do create object scripting.dictionary. We use the object dictionary.add command with a key, and we give it an item. So here our keys are actually 1, 2, 3, 4, and I give it server 1, server 2, server 3, server 4. I can iterate through it, and I can then display each item in the dictionary. Now, for example, though, I could say object dictionary.add name, add address, add phone number. So these keys don't have to be numeric values, which is how it makes it easier to find them in the future. You actually could then say, find my item of name, and it will go and use name instead of a numeric, such as 1, 0, whatever. We looked at a lot of manipulation with text and arrays. We talked about dynamic arrays. We talked about two-dimensional arrays. We looked at how we open and connect to an outside file and use a few different commands to manipulate it. We can use inString to look for a specific value within a string that we read, or we can use a split, which will actually create multiple strings out of a single string with a specific delimiter. We also learned about opening and closing files. And then finally, we talked about dictionaries and how dictionaries differ from arrays by using those keys. That is all the information I have regarding arrays and VBScript, so I hope to see you next time.